everyone, hi and good evening people. I welcome you all to the platform of Sri Chaitanya. My name is Shubhajit everyone, and I am here to take a session on the chapter, basically on the chapter that is Gravitation and the Newton's laws of motion. As you all people know that we are here for getting my point. In our today's session people, we are here to understand about the top 25 questions related to the gravitation as well as the force and laws of motion. Now as we talk about the theory of gravitation, it has been taught in our previous session. When we talk about the theory of the force and the Newton's law of motion, we will be talking about the theory first today, right now. Okay, after that we will be moving to the numericals. We will be moving towards the numerical. First of all, let us complete the entire theory. Let us talk about the concept of the force and the Newton's laws of motion, so that we can have a clear understanding what basically we are trying to do, so that you can have an strong foundation by learning into those, and you can move into the top questions. You can solve any of the numerical that has been present over here. Fine. So let us start with the session, everyone. The gravitation, the topic gravitation has been taught in the previous session. I request you all to please see the previous video. It has been taught entirely. Now in our today's session, we will talk about the Newton's laws of motion. If we talk about the Newton's laws of motion, the first thing that you have to prepare, you have to understand, is all about the force. Okay. Now I am taking in consideration that you people have completed this particular chapter. You have understood this particular chapter, and this is just a type of revision. Getting my point? So we will be talking about a lot of things. We will be talking from the basics, then we will be jumping towards the all the question and answer and how to solve and what are the things that we have to take care of first and then. So as far as the Newton's law of motion is concerned, the first thing that we have to understand is all about force. What do you mean by force? Getting my point? In our junior classes, we have defined the force with the name of push and pull. But basically, at that particular time, we were not that much mature to understand the few words. Okay, so that is why we have to simplify the definition of the forces. Now, when we talk about the force, everyone over here, so force is an external agent. It is an external agent by which it tends to, or you can say it tries, or it is changing the state of the body. When I'm saying the state of the body, it means that if the body is in rest, so if there is an external effort which is acting on that particular body which is in rest, it will be trying its best, or it will be changing the state of the body. That means if it is in rest, it will be changing into the motion. If the body is in motion, it will be trying to change its state into rest. So that is what the force is all about. So force is always an external agent, everyone. Getting my point? Suppose for an example, a football is lying on the ground. A football cannot move by itself. Getting my point? There should be certain kick which should be applied on the ball so that the ball can move. So that kick is what? That is the external agent that we are talking about. Getting my point? So when we talk about the forces, force is an external agent by which it changes or tends to changes the state of the body, which is from rest to motion or motion to rest. This is what the force is all about. When we talk about the forces, force is a vector quantity, everyone. Okay, it can be positive, it can be negative, it can be zero, as we all know. The SI unit of force is basically, when we talk about the SI unit of force, people, the SI unit of force is kg meter per second square. Please do remember this. Okay, kg meter per second square, that is the SI unit of the force. But since Sir Isaac Newton has given all the information of the forces, to give him a respect, we, instead of writing kg meter per second square, we write Newton. And how we are representing the Newton, that is capital N. Getting my point? That is all about the forces, everyone. SI unit. Then there is a very sometimes it may be asking you about in 1 marks of question, that what is the CGS unit of force. The CGS unit of force is gram. The CGS unit of force is gram centimeter per second square. Gram centimeter per second square, which is called as dyne, everyone. D-Y-N-E. That is the CGS unit of forces. Now moving next, we have to know the conversion of this. What is the conversion of this? Please do remember, everyone, that is 1 Newton. Please do remember the conversion. 1 Newton will be equals to 10 to the power 5 dyne. this is something that you should remember because it may be it may be in the question that in the terms of dyne you have to convert in the terms of Newton. So it should be very much clear. As I have told you, the force is nothing but it is a vector quantity, so it can be positive, negative, and zero. That is what the force is all about. Fine. After the understanding of the forces, we have to go through the balanced forces and unbalanced forces. So to understand the balanced forces and unbalanced forces, we have to understand about the net force, everyone. So if we talk about the net forces, I request you all to please pay attention. Okay. So when we talk about the net forces, people, it is, I believe you might have gone with the net forces in your junior classes. Okay, so if we talk about the net forces, just allow me to make a simple figure for you. Okay, fine. Consider there is a body of M which is lying on a surface, white color, as you can see. Okay, so we will be just copying it. Fine. Now there are few things that you have to remember while this. So when we talk about the net force, everyone, what do you mean by net forces? So try to understand, people, and it is very simple to understand. If you understood this, then the balanced force and unbalanced force is very much clear to you, because there is not a direct question that is going to be asked in the balance and the unbalanced forces. It is an indirect question that will be there. Okay, so let us consider the first figure where a body is there which is lying on a particular surface. Okay, and if we are applying a force in this particular direction, as I believe you are able to see the direction of the force, okay, which is in this direction. So suppose that this force is F1 and which is trying to apply a 10 Newton of force. Getting my point? So if this particular force, 10 Newton of force, is applying on this body, then the body will be start moving in this direction, as we know, basic logic, and it will be moving with the speed according to the 10 Newton. For an example, like suppose that if I apply 10 Newton of force, and then might be it is moving with 5 meter per second speed. Okay, if I increase the force, it will be increasing the velocity. Fine, so this is what it is there. So this body can move with 10 Newton of force according to the 10 Newton of forces. Now suppose that if another force in this particular direction has been applied on it, another force in this particular direction, F2 of 5 Newton, is been applied on this particular direction, people. Okay, then if I want to know ki you people can understand that by application of 10 Newton only this body can move in this direction. Now we are applying 5 Newton more in the same direction. So I want to know that overall what will be the effect of the forces on this particular body which will be trying that particular body to move in this direction. What will be that effective force? What will be that resultant force? What will be that total force? Getting my point? So what will be this? So please do remember in this particular condition, if the direction of the forces, forces applied on the body, or you can say act on the body, applied will be fine. On the body are same, then in that particular case, then what we have to do? We have to do an addition, everyone. What we have to do? We have to add all the forces. We have to add all the forces. In the very simpler way, we can say in this particular condition, the F net, which is the effective force which is applying on this particular body, will be 10 Newton plus 5 Newton will be equals to 15 Newton of force. So this body, 15 Newton of force is acting on this particular body to move this particular body in this direction. So every single time we cannot say that this direction or that direction. So we have to specify that which direction. So let us consider if we make an half of this particular body according to our hands, it is going to be right direction, it is going to be left direction. So the body will moving towards the right direction, everyone. Simple and sweet. Okay, this is what it is there. Fine. Let us move to the next one, the next figure, everyone. Suppose that there is a force which is applied on the body in this direction, and the name of the force is F1, which is equals to 10 Newton again. Similarly, there is another force. Now the direction of the forces is changes. Okay, so F2 is going to apply in this particular direction, that is 5 Newton, people. Now we want to understand what will be the effective force which is trying to act on this particular body in the opposite direction, people. Fine. As you can see, the F1 is towards the right, F2 is towards the left. So the forces are acting opposite to each other. In that particular case, the same thing is there. If direction of the forces, if the direction of the forces are different, then what we have to do? Sorry. If the direction of the forces applied on a body, it will be more correct, applied on the body are different, then what we have to do? We have to subtract. This is basic that I believe you people already know. Subtract. In this particular case, what will be the F net? So the value of F net is coming out to be 10 Newton minus 5 Newton. That is going to be 5 Newton, everyone. In which direction, if you try to understand, it is towards the right. It is towards the right. I believe it is clear to all. Similarly, if you try to focus on the figure number 3, suppose that there is a force which is applied on the body in this particular direction. That is going to be F1. F1 will be equals to 10 Newton in this particular direction, and F2 again in this direction, F2, that is going to be 10 Newton again, people. In this particular case, you can just simply say, sir, this is the case of the second one only. The second concept is only there, है ना? Second figure concept. So what will be the F net for this? The F net for this, it will be the 10 Newton minus 10 Newton. That is going to be 0 Newton, everyone. Now, if F net or the effective force on acting on a body is equals to 0 Newton, then the body is not going to change its state. Please do remember, if this is the condition, then please do remember one thing. The body is not changing its state. Whatever the state it is in, it will be in that state itself. It is not going to change its state. If it is in rest, it will be in rest. If it is in motion, it will be in motion. If it is rotating, it will be rotating. Getting my point? So body in this particular case, in this particular condition, the body is not going to change its state. If it is so, let me make a little bit more space so that I can teach you more in this. Just a second. I believe it will be taking a little bit of more time. I have wrote a lot of things over here. Fine, people. So this is what it is there. Now, if you try to understand in this particular case, if you are trying to understand in this particular case, people, so you will be able to understand there are few things that is not over here written, but you can understand from here itself. That if the body in this particular condition, if F net is 0 and body is not changing its state, in this particular condition, the body will be not changing its state. That means if the body is in rest, it will be in rest. If the body is in motion, that it will be in motion. If the body is rotating about with the reference of our axis, it will be rotating like that only. So this is the state. Instead of writing this particular line, we can say one word, and that word is equilibrium. So the body is not changing the state after the application of force also. After the application of force also, the body is not changing its state. Then this particular condition is known as equilibrium. So there are a lot of equilibrium, everyone. You might have heard about balance equilibrium. You can say stable equilibrium, unstable equilibrium, neutral equilibrium. And when we talk about the equilibrium, it is in the terms of grade 11 physics. We can say it is static equilibrium, dynamic equilibrium, or rotating equilibrium. Getting my point? So this is what it is there. Now, as you can see, the F net is equals to 0. This condition leads to the equilibrium, and if the forces are equals to 0 because they are equal and opposite, so this is the condition of the force which is known as if F net is equals to 0, then this particular condition of force will be known as balanced forces. It is called as balanced forces, everyone. Simple. Getting my point? Now, if you look into this first and the second figure, everyone, if you look into the first and the second figure, you can just simply say it out that the first and second figure, in both first and the second figure, you can say the body are in motion. In both of the cases, you can simply say over here that F net is not equals to 0. It can be anything, but it is not equals to 0. This is the case which leads to unbalanced forces. This is the case which leads to unbalanced forces, people. Getting my point? One more point, please do write it down. That in the case of unbalanced force, in the case of unbalanced forces, the body will be accelerated. The body will be accelerated. Please do write it down, everyone. So when we talk about the body will be accelerated, it can be positive acceleration also, it can be negative acceleration also. There is no doubt in that. Okay, so it will be accelerated. Fine. I hope this much is clear to you and you have understood this much. So this is the entire concept about the balanced forces and unbalanced forces, everyone. And if someone asks you about the balanced forces, what about the accelerated motion in the balanced forces, please do write it down. In the F net, since it is in equilibrium, it cannot be having any of the acceleration. Okay? Because every single thing is constant in this. So we have talked about what? We have talked about the forces. I have given you the understanding of the forces as a vector quantity, SI unit, the conversion, every single thing, balance, unbalanced, Newton, and the net forces is also done. If we talk about the inertia, people, that is very much important, because I'm assuming that you people have gone through this and this is what a revision that is going on. Okay, so that is why I'm going a little bit faster. So if we talk about the inertia, what do you mean by inertia? So inertia is the property of a body, to be very exact. Okay, like for an example, if you are trying to push me for fraction of second only, let us suppose for fraction of second only, I will be trying my level best to resist your force. Getting my point? So when you are applying the force on me, what you are trying to do is you are trying to change my state. Getting my point? And I will be trying my level best so that I resist your entire force so that I cannot change my state. So this tendency of not changing the state which is applied by the body, that resistance, everyone, which is the tendency of the body, the resistance of the body which is applied by the body to not change the state of not change the state when there is an application of force which is applied, that particular tendency or resistance is called as inertia. Okay, that is called as inertia, everyone. Fine. And please do remember a few more things, everyone, about the inertia. In inertia, please do remember that the inertia is directly proportional to mass. Is directly proportional to mass. More mass, more inertia. More resistance will be there. Hai na? Suppose that you can push a cycle. Cycle will be also trying its very best to resist the forces. But unfortunately, it will be moving. What about the truck? For move the truck, you have to apply more forces. Okay, so it can resist till more time. So that is why inertia is directly proportional to mass, everyone. When we talk about the inertia, there are three different conditions of the inertia, that is inertia in rest, inertia in motion, and inertia in direction, people. When we talk about the inertia in rest, what do you mean by that? For an example, and a very simple example is there. You are sitting on a bus or a car, whatever, okay, and you are also in rest. The car or the vehicle is also not moving. It is also in rest. Now, though your entire body is in rest, the vehicle is in rest. Now, suddenly, the car starts to move forward. Getting my point? Now, what is happening? Your lower body, it completely attached to the ground, everyone. That is the surface of the vehicle. So the surface of the vehicle is moving forward. Your lower body is also moving forward, but your upper body, it is in the rest. It is in the state of rest. And it is trying its very best to be in the rest, but unfortunately it cannot be done. So that is why whenever the car is moving, sudden the start of the car is there, your body is lying backwards. Why? Because your upper body was completely in rest and it is not trying to change its state. Okay, that is why that compensation will be backwards. This is what the inertia in rest. When we talk about the inertia in motion, everyone, what do you mean by inertia in motion? It is very simple. Same the vehicle example. Suppose that you are sitting in the vehicle is moving. Okay, suddenly there is a stop. So your entire body was in motion. And we are talking about inertia. That means your body is not trying to change the state. But unfortunately, the brake has applied. So the brake has applied. That is why your body is lying. It is trying to move forward. Why? Because your body was not. The body was not in the. The body was in motion, and it is trying its very best to be in the motion. But unfortunately, it can't be. Okay. That is why it is lying forward, everyone. That is what inertia in motion is. Then we talk about the inertia in direction, everyone. Suppose that you are moving in a very straight road. So according to your body, your inertia is straight only. Suddenly you have taken a right turn. When you are trying to take a sudden right turn, your body will be shifting towards the left. Why? Because according to your body, the body was in the straight direction. So its inertia is in straight. It will be trying its very best to be in straight. But when you have taken the right turn or the left turn, the body will be shifting towards the different direction. Left or right. This is due to the inertia and direction, people. Okay, I hope this much is clear to you and you have understood about the inertia in direction, inertia in motion, and inertia in rest. This is all about it is there. Since we have talked about the inertia, now we can talk about the Newton's first law. The Newton's first law is also considered to be known as the law of inertia. So what is the Newton's first law? It says, as we can understand that what is inertia? Inertia is like it is a tendency, it is the resistance, everyone, that body is doing whenever there is an external force is applied on it, okay, to not change its state. But unfortunately, it will be changing its state. Getting my point? So what does the first law says? That a body at rest will remain at rest. A body at motion will be remaining at motion, continuing being motion in a straight line with a uniform speed unless it is compelled by an external force to change the state of the body. So it is saying that a body is in rest, it will be in rest. A body in motion will be in motion. Okay, because the inertia is like that, but it will be changing its state. The motion will be rest, the rest will be in motion when an external force is applied on it. So that is known as the first law of motion, everyone. That is known as the first law of the motion. Fine. If the first law is very much clear to you, now we will be moving towards the momentum, everyone. In a very simple definition of the momentum, momentum is defined as the product of the body, the product of the mass of the body and the velocity of the body on which the body is moving. That is known as momentum, everyone. And again, when we talk about the momentum is represented by P, and yes, it is a vector quantity, simple words. Okay, it is represented as small p and it is a vector quantity. It can be positive, negative and zero. If we talk about the SI unit of it, that is mass, that is kg, everyone, and velocity, that is meter per second. Kg meter per second, that is known as the momentum of the body. Getting my point? So formula for finding out the momentum, that is P equals to m into V. Mass into velocity, everyone, of the body. Since when we have understood about the momentum, let us talk about the second law, everyone. Now in our junior classes, we believe till grade 9, still we haven't learned anything. We always believe the second law is nothing but F equals to ma. but it is wrong. F equals to ma is not the second law. F equals to ma is found by the second law, or you can say it is derived by the second law. What does the second law says to us? A very simple example, everyone. Let us suppose there is a body like this. The first condition is the body is completely in rest. If it isn't completely in rest, getting my point, the first condition of this particular body, that this particular body is completely at the first condition, having a mass m, this particular body is completely in rest. The first condition, the body is in rest. If the particular body is in rest, if we want to find out the momentum of this particular body, what we can say? We can say that the P initial will be equals to mass into velocity. Initial velocity u is there. We know the value of u is equals to 0. That means the P initial, the momentum initial is equals to 0. Simple value. Getting my point? Now, if after few seconds, if there is a force which is applied on it, suppose that if there is a force which we are trying to apply on the body, if there is a force F, we are not defining what is the value of F, but as I have told earlier also, suppose that it is 10 Newton, so it will be moving according to 10 Newton, for an example 4 meter per second. If you increase the force, velocity also increases, okay? So if we have applied the force on this particular body, which is trying to move this particular body in this particular direction, okay? Now this body will be in motion, as we can know. If this particular body is in motion, in that particular case, for an example, suppose that this point is our final point. Suppose that this point is our final point. Final. Now, as we all people know, that the same force F will be applying on it. The same force F will be applied on it. F force applied on it. Now, since after the application of force, it was moving at a final point, let us say, the velocity can be anything, but it is not equals to 0. It will be something, 10, 20, 50, 2, 4, anything, but it is not equals to 0. In this particular case, if I want to find out the momentum, everyone, in this particular case, if I want to find out the momentum, so momentum at the final can be written as mass into final velocity. As we know, in this particular condition, final velocity is not equals to 0. So final momentum will be like this only, m into v, which is more than 0. Okay, so at earlier state it was 0, now it is m into v. So this change has happened due to the application of this force. If you increase or decrease this particular force, there will be increase and decrement of this the final velocity, final momentum. If you increase it, because of the velocity increases with respect to the forces, the momentum also increases. If you decrease the forces, it will also decreases. So whatever it is going to happen, it is directly proportional to the force that we have applied. Okay. Now from moving to the point 1 to the point 2, we can understand there will be a little bit of time, a fraction of time or little bit of time that might have taken. So if I want to write this entire concept in the form of a mathematics, what we can say? We can say the change in momentum with respect to time, everyone. Change in momentum with respect to time is directly proportional to the applied force. Applied force. Simple words. Applied force. Getting my point? Now, in that particular case, F will be directly proportional to change in momentum will be del V, del P divided by T. This can be written as F will be equals to, F is directly proportional to, that is, we can say final minus initial by time T, everyone. F is directly proportional to what is final, that is m into V minus m into U divided by T. Similar cases, F will be equals to what? M is common because mass is common, so we can write V minus U by T, everyone. What is V minus U by T? If you remember, it is nothing but the acceleration. So in this particular case, what we can write? We can write F is directly proportional to MA. To remove this directly proportionality, we have to put a constant, people. So F will be equals to KMA, whereas the value of this particular K is a constant and it is equals to 1. Similarly, it again we can so that we can find out the value of 1. So it will be M into A. So as you can see, F equals to MA is not the second law. F equals to MA is the formula that we have found out to find out the magnitude of the forces from the second law. F equals to MA is not equal to, it is not second law, it is derived from second law. What is second law? That the applied force on a particular body will be directly proportional to the change of the momentum with time. Now, I believe this much is clear and you have understood this much. So please do remember this formula, that is F equals to MA. If we move to the second law, the same thing is there. The rate of change of momentum. Rate of change means, what is the meaning of rate in physics and math? It means with respect to time. The rate of change of momentum of a body is directly proportional to the applied force and taken place in the direction in which the force has been acted. So force is directly proportional to change in momentum by time taken. Fine. After that, we have talked about that over here, everyone. I'm extremely sorry. After that, we can talk about like this. That if you talk about the impulse, what do you mean by impulse? Well, impulse is what? It is a force which is transferred in another body in a very fraction amount of time, or you can say in a very short interval of time. For an example, if you are kicking a football, so the contact between the leg and the football is very, very short period. So the force that you have transferred from your leg to the football, it is called as impulse. Another example, like if we are playing cricket, the contact between the ball and the bat is for the fraction of seconds, a very short period of time. Still, a large amount of force is being transferred from the bat to the ball, and the ball is acting according to the force that has been applied. Getting my point? So that is called as the impulse, everyone. So when we talk about the impulse, impulse is equals to force into time. Simple word. SI unit will be Newton second. SEGS unit is equals to time second, and it is a vector quantity. There is one more thing that you can understand from here. Now, I'm writing over here, everyone, that the impulse, as you can see, force can be written as change in momentum by time, multiplication of time, everyone. This time in this time is cancelled out. So impulse can be also represented as change in momentum. Change in momentum. It is one of the formula. Please do remember this. Okay. The impulse can be also written as change in momentum. The impulse can be also written as change in momentum. As equals to del P by this. So this is one of the concepts that you should remember. That is all about the second law, people. If you move towards the third law, which is very easy, because we normally used to remember this, that every one body is exerting a force on the another body, and the second body is exerting the force in that first body, and it is equal and opposite. For an example, if I am the person and I'm trying to push a wall, everyone, so first I am applying the force. Getting my point? So since the force, application of force is started by me, let us take my force as known as for action, everyone. So action, and the wall will be also giving the reaction to me, but in the opposite direction. That is, for every action there will be opposite and equal reaction. That means that we can say that the F1 is directly proportional to the negative of F2. Let us say it is F2. Let us say I have applied, that is known as F1, everyone. Okay, the force that I have applied, that is F1, that is action, and the force that is given by the wall, that is F2, that is reaction. So F1 will be equals to the opposite of F2. And this negative sign is given to make us understand that the direction of the reaction force is changed, it is reversed. So that is why it is there. Now, let us move to the next one, everyone. Let us talk about the law of conservation of momentum. So law of conservation of momentum is a very simple thing. We don't have to bother that much. Let us suppose that there is a body of mass m1. Let us change the color. There is a body of mass m1 and mass m2. Getting my point? What is happening? The mass m1 is moving with the velocity of u1. The mass m2, it is moving with the velocity of u2. Getting it? If I want to, this is what it is there, and we are taking in consideration that the u1 is greater than u2. Fine, u1 is greater than u2. In that particular case, the u1, the body m1, will be colliding with m2 like this. So this is the state of collision, everyone. This is the state of collision. In this particular state, what we can say is that this is the m1 and this is the m2. As we can understand from the third law of motion, the m1 will be applying the force on m2 in this particular direction, that is m1, that is for an example f1 will be applying a force on 2. Similarly, the body 2 will be applying the force on body 1, or equal and opposite, as you can see, the collision, everyone. After the collision, the body m1 and m2 will be moving apart. When they are moving apart, there is a slight change. Now, the body m1 is moving with a new velocity v1 and body m2 will be trying to move velocity in v2, everyone. In this particular case, what is law of conservation says? In this particular case, the law of conservation says that momentum before collision will be equals to momentum after collision. That is what it is trying to say. Momentum before collision will be equals to momentum after collision, everyone. Now, in this particular case, what do you mean by this? When we talk about momentum before collision, means the sum of these, both of the two momentum, m1 and m2. If you try to sum this, suppose that it is 100. So the after the collision is also 100, but the individual will change. How? For an example, if this particular body is moving with 70 and this particular body is having the momentum 30, total is 100. After the collision, it might be moving with 60 and it might be moving with 40, but in total it is 100 only. That is what it is trying to say. So you might have learned about a formula, that is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. See, that is not the formula. That is the formula according to this condition. But actual formula is momentum before the collision will be equals to momentum after the collision. So please remember this, not that. Fine. I hope it is clear to all and you have understood this much. So let us try to solve few of the question, people. I request you all to please try to solve this particular question. This is all. This is all. Please try to solve this. Please try to solve this. Now, how to solve this particular question? It has been said a field gun, there is a gun of mass. So let us solve this thing, everyone. Okay. So if we talk about the solution, people, if we talk about the solution, a field gun of mass 1.5 ton. So mass of the gun that is given is, that is 1.5 ton, which will be equals to, as you all know, that is 1.5 multiplication of 1000 people. And so it can be written as 1500 kg. So we have found out the mass of the gun. After that, fire a shell. There is a shell, everyone, or you can say a bullet of mass. It is written as mask. Let me rectify this. This is S, है ना? Mass of 15 kg. Mass of 15 kg. So we have the mass of the shell, everyone. I'm writing S. That is 15 kg. Fine, no problem. What do we have to find? We have to find velocity of, and the velocity is also given. The velocity of the shell is also given. That is 150 meters per second. Fine. We have to calculate the recoil velocity. It's a very straightforward and a simple question it is. So we will be using the law of conservation of momentum. So we know that momentum before collision, will be equals to momentum after collision. So after the collision, the shell was moving. Before the collision, everyone, when the fire was done, the gun has moved backwards. So that is the recoil. So mass of the gun multiplication of the velocity of the gun, which is called as recoil, everyone. Which is called as recoil, will be equals to momentum after the collision. So the bullet was moving. So mass of the bullet or the mass of the shell multiplication of velocity of the shell. So it is given as 1500 multiplication of velocity of the recoil, everyone, will be equals to mass of the shell. That is, mass of the shell is given as 15 multiplication of what? That is that is given as what? Velocity. That is 150, everyone. 150. Getting my point? If it is so, we can find out the velocity of the recoil will be equals to 15 multiplication of 150 divided by 1500. 1 0 1 0 cancel. This cancel this. That is going to be 10, and it is going to be 5 times. It is going to be 3. It is going to be 2. Okay, so it is coming out to be 1.5 meter per second. Now there is one catch. What is the catch is? The answer is 1.5, that is for sure. There is no any problem in that. But what is happening? What is happening, everyone? Key, when we talk about the recoil, the bullet is moving forward and our body is bullet only, which is moving forward. So according to us, the direction is forward. But when we talk about the recoil velocity, the direction of the recoil velocity is opposite to it. Getting my point? So there will be an option of 1.5 meter per second, and there will be an option of minus 1.5 meter per second. Getting my point? So if it is, the option is written as minus 1.5 meter per second, choose that. Because recoil, when we talk about the recoil, it is opposite to the direction of the bullet. So it will be represented as opposite of the direction. That is why negative sign will be representing on that. And this will be your answer, people. This will be your answer. I hope it is clear to all and you have understood this much. Fine. Fine. Let us move forward, people. Let us move forward to our next question. Now, please let me know your answers for this. Now, a rocket-driven sledge speed up from 40 meter per second to 55 meter per second. So, as you can see over here in the solution, people, sorry. If you go with the solution for this, we can see there is a change in velocity which is there. Change in velocity means 55 meter per second to 40 meter per second. Getting my point? And this is the change, everyone. That is the change that has happened, initial and final. And the time that has taken place to do this particular change, it is 5 seconds. 5 seconds. Using an engine that produce how much of thrust? So engine is producing F, everyone. When we talk about the thrust, it is nothing but the force only. So thrust that has been used, that is 3500 Newton. Fine, no problem. Okay, thrust. How much thrust? Now we have taken out how much thrust. So suppose that if it is F1, then we have to find out the F2. How much thrust? How much thrust would be needed to get the same increase in speed in 2 seconds? So instead of 5, now the time has changes to 2. So we need the same increase in speed, means 40 to 55, but the time has decreased. So if the time is decreased, that means we have to apply a more thrust. If we have to more thrust, then according to that we have to talk about it. Getting my point? I hope this much is clear to all. So it is pretty much simple, everyone. There is no any point. There is no any. If you say, if there is any how to solve this question, it is very different type of question. It is not. It is very much simple. So let us find out the change, although it is not going to help you out in anything, but still. So in this particular case, what we are having, we have time. Let us say it is T2. Let us say it is T1. T1, T2, force and force. Getting my point? So we have force and time. We have to find out the second force. So if I am not wrong, we can write over here, people. What we can write? We can write the change in momentum will be equals to impulse. Simple. So change in momentum, that means that the momentum at final minus momentum at initial will be equals to force into time, if I'm not wrong. Yes, force into time, if I'm not wrong. Fine. If that is the case, everyone, if that is the case, since we can understand, so this is what it is there. So in this particular case, we can say that we have to take the same speed. That means the velocity is same. If the velocity is same, we can understand the mass is also same because it is not given anywhere. Okay, that means the momentum at the final and the momentum at the initial will be equals to, both will be equal. That means the momentum at final will be equals to momentum at initial. In that particular case, we can say F2 multiplication of T2 will be equals to F1 multiplication of T1. In this particular case, we have to find out the F2. F1 value is 3500 multiplication of 5 divided by T2, everyone, that is going to be 2. Simple. If we are trying to solve this particular case, how we are going to, so it is 35,000, 5, what will be the answer, people? What will be the answer? So if I'm not wrong, it is, the above will be equals 35,000. It is 17,500 divided by 2. The answer is going to be 17 half. 17 is 8. 25 is equals to 7. 14. 50. 8750. Is there any answer? 8750 is Newton will be the answer. Option B will be the correct answer. And here the option B. Okay. I hope it is understandable and you can understood this much. Now, the principle of conservation of linear momentum state that the linear momentum of the system can be changed only if the external force is applied. What do you mean by that? In this particular condition, whatever it is acting between the two different bodies only. There is no any third force which is applied on it. So whatever the conservation is happening, it is happening between the two bodies. If we have to change this particular conservation, then there is an external force should be applied on this so that the conservation is completely changed. Now it is not going to be conserved. It is different. Okay, so for the conservation, it is very much required that there should be no any external forces. If the external forces applied on that entire scenario, it is not going to be conserved anymore. Let us talk about this particular question. Again, it is a very good question, people. What we have to find over here is, as you can see over here, a body of mass m kg starts from rest, people. Solution for this. A basic question it is. Do not worry about the answer. Okay, if you look into the answer, that it will be very much stressful. A body of mass m kg start from s, so that the mass is given as m, and the initial velocity is given as 0 because it is starting with the rest, and travels a distance of s meter. So s is the distance that has been traveled in t time. So the time is also given to you. Getting my point? The force acting on it is. So we have to find out what? We have to find out the value of force. Fine. From the second law, we have found out F equals to ma. Simple words. So we will be using, we have to find out the value of A. For A, we know we required final velocity, initial velocity, and the time. Time is given to us, but we do not know, we have the initial velocity, but we do not have the understanding of final velocity, everyone. But in this particular case, what we can find out is, let us go with the equation of motion, S equals to ut plus half a t square. Why? Because we have the value of t, we have the value of a, we have to find out the value of a, we have the s. So initially it was completely in rest, so it will be 0. So we have found out s equals to a t square by 2. In this particular case, if we want to find out the value of a, what will be the value of a? It will be 2s by t square. The value of a is 2s by t square. We'll just take this particular value, put it over here. So in this particular case now, the value of s will be coming out to be, the value of m is there, the value of a will be equals to 2s by t square. 2s by t square. Or you can write f is equals to 2ms by t square. Newton, people. That will be your answer. Simple. Okay, that will be your answer. So if you look into the options, then it is going to be very much disturbing to you. Okay, if you just look into the simple solutions, it is like this. So the answer, if I'm not wrong, that is going to be option A. Fine. Now, this is a very pretty question. It is a very fine piece of question, everyone. Okay. Yes, so let me help you out to solve this thing. Since it is, what we have to find out over here is, a mass of 100 grams, this is 100 grams, this is the mass of 100 grams, people. A mass of 100 grams strikes the wall with the speed of 5 meters per second. Fine, no problem. So this particular body is moving in this particular direction, and it is having a speed of 5 meters per second. Fine, no problem. Now, at an angle as shown in the figure, so it is making 60 degree from vertical, everyone. It is making 60 degree from vertical. And it rebounds. So as you can see, it is rebounds also. It is rebounding also. Fine. With the same speed, same 5 meters per second. If the contact time is 2 into 10 to the power minus 3 seconds, what is the force applied by the wall? So, contact time is given to us, so we all people can understand when we talk about the impulse, everyone. Impulse is equals to what? Force into time. Fine, simple, short period of time. We have to find out this force, and this impulse can be written as change in momentum. Change in momentum will be F multiplication of T. We do have the value of T. So, if we want to find out the value of F, it is change in momentum by T, everyone. Simple words. Okay. The force can be found out by change in momentum by T. If we talk about the change in momentum by T, there are a lot of things that we have to take care of. Okay. Now, in this particular question, you should have a very good understanding of trigonometry, everyone. Otherwise, it will be very much difficult for you. Getting my point? So the technique that I'm going to use, or the method that I'm going to use, it is called as resolution of forces, where a force of this is going to split into two. The angle between this with the vertical, it is 60 degrees, so I can write it down in the horizontal way. I can write it down. It is going to be V cos 60. Sorry, it is V sin 60 degree, and it will be V cos 60. Fine. Similarly, after the rebound, the ball is moving in this particular direction, so it will be like this. In this particular direction, I can say it is V sin theta, sin 60. And in this particular direction, it is called as V cos 60. Now, if you try to understand, what we have doing is, if we go with like vertical direction top and vertical direction top, there is no any change. We have to find out that change. The change is happening in the horizontal direction. One is moving in this, one is moving in that. So if it is so the final can be written as, so this is the velocity, everyone. We have to put the mass also. So as you can see, what we have to do is, let us say this particular point, so it is written as negative because the body, one of the body is moving in that direction and it is moving in this direction. So negative of m v sin 60, that is final, minus initial, again this v, sorry, it is m v sin 60 people, divided by the time. What is the time? That is 2 into 10 to the power 3. And in that particular case, you can see it is going to add up and it will be having the same value. The f can be written as 2 negative of mv sin 60 degree by 2 into 10 to the power minus 3. The value of f is going to come, it is minus 2. What is the value of mass? 100 grams, everyone. That is 100 into 10 to the power minus 3. It is now in kg. Sin 60, the value of the velocity, that is 5. Then we have the sin 60. What is the value of sin 60, everyone? That is root 3 by 2. Trigonometry to theek hai meri. Root 3 by 2. So it will be 2 into 10 to the power minus 3 into 2, same, hai na? So in that particular case, we can say this 2 and this 2 is cancelled out, fine. This 2 and this 2 is cancelled out, that is also 50 over here, fine. Now this 10 to the power 3 and 10 to the power minus 3 will be cancelled out. What we are getting is, we are getting the value of f will be equals to 50 into 5, that is 250. And root 3, everyone. 250 root 3 will be the answer. And the body is moving towards the left hand side. So it will be, I'm writing L for that, left. That will be your answer. Option C. Fine. Option C. That is the entire calculation. You can do it. You should know these two things, resolution of forces. You should have the understanding of the trigonometry. Then only you can find it out the answer. Fine. So there are a few more questions, everyone. Easy only. Not that much tough. You can solve it down. So as you all know, the registration date is on 28 September. Exam date is on 28 September to 12 October. You have to visit the Sri Chaitanya site to get registered for the score examination, everyone. Okay, I hope you have found out this entire session very interesting and very helpful. So do like, share, comment and subscribe the channel, and you can follow us on the Instagram, Telegram and few more places. Okay, so this is all for the day. Thank you everyone for joining. Thank you everyone, and I hope it is going to help you out. Please try to solve all the questions that is given in this. It is more than enough for you. Okay, thank you everyone. Bye and have a nice day. See you all. Thank you.